Hey class, welcome back to Chapter 3, Linear Relations and Equations. Today we're looking at Exercise 3H, Transposition of Formulas. So sometimes it's useful to find the value of a variable that is not already the subject of a formula. This might come in handy if you repeatedly need to solve for that variable throughout the problems or different problems. It's just to have it already rearranged for you. The mathematical term for rearranging an equation is transposing or transposition. Okay, and this links in really well with what we looked at in exercise 3E for solving literal equations. So I've got 3 examples for you today. We're going to transpose each of these 3 to make A the subject. So the first thing we need to do here in V equals U plus AT, which if any of you do physics, you might recognize this formula, is we're going to start by subtracting U. So remember, sad mob, okay? So we deal with the addition first by subtracting U from both sides, okay? And we end up with V minus U equals AT. And then to get A on its own, we need to divide both sides by T. That therefore cancels out this T. And our final equation is A equals V minus U over T. So if you were a physics student and you needed to calculate the acceleration often, it might be handy to have each of these or have this equation rearranged for V or U or A or T, depending on what it is that you need to solve. Okay. The next one is the area formula for a trapezium. So the first thing that we need to do, or we have 2 options here, we can either divide by h or we can multiply by 2 to get rid of this half. I love getting rid of fractions first, so I'm going to start with that. 1/2 times 2 is 1. So if I multiply a by 2, I will get this equation as my next line of working. Okay, and now of course working in towards the brackets, we need to divide both sides by h, getting rid of that. Okay, and we get 2a over h equals a plus b. Also, please note that yes, there are 2 a's in this formula. We're looking for the lowercase at the moment. And our last step is to subtract b from both sides, which I've run out of room on in between there, so I will write it out the front. And we get 2a over h minus b equals a, or a equals all of that. Okay. One last one. We have a squared plus b squared equals c squared, which is, of course, Pythagoras' theorem. So, again, sad mob, we're going to deal with the addition first. We're going to subtract b squared from both sides. That gets rid of that. What we have left is a squared equals c squared minus b squared. Our last step is to get rid of that squared. The opposite of squared is square root. Okay? So we're going to square root both sides and writing it neatly. The square root of a squared number is just the number that you were squaring in the first place. So a equals c squared minus b squared. Now, a quick reminder, you can do all of this on your CAS, but remember if you do that, you need to put the multiplication symbol in between the a and the t here, and in between the half in the bracket and the h in the bracket here. Otherwise, your CAS will think that all of this is one big variable and it will confuse itself, okay? So remember to put your multiplications in between each of your variables if you're using the solve function on your CAS, but the solve function will rearrange each of these for you, okay? As always, guys, good luck with your work. If you have any questions, let me know, but otherwise I will speak to you all very soon.